Well, again, thank you for inviting me to look at the SEG. This is pretty amazing stuff.
You're welcome. Absolutely.
So how did you first get interested in the SEG? What was it that, you know what, let me back up before that. What was it that first got you interested in gravity modification? Did this start with the SEG?
No, it was way before. I'd have to say it was back when I was, probably was like the free energy stuff, which also went into gravity modification, but that interest in that topic, including UFOs, was really when I was in my started when I was 14.
Okay.
And I was building little things out of wood and like balsa sticks and glue, and also had a small Tesla coil a guy helped me make. So I played around with a lot of that, and Gene Lewis Nodham was on like Netscape. Yeah, so I was going to the library all the time, printing out plans and blueprints and trying to build some of the things he did. And so that really had my interest for a few years when I was that age. But I guess after I got my driver's license, I just kind of put it all aside and forgot about it for a while.
Yeah.
But then when I turned 28, I was 28 in December, January time. I was having like this, I want to get back to inventing, do things like when I was doing the fun stuff when I was 14, 15 years old. And I went to sleep and had this dream about seeing a kind of a lathe with these interweaving magnetic, they were just energy fields.
Okay.
And then I woke up, and the guy I was working for called me up after I woke up, and he called me and was wondering if I had any knowledge about free energy machines, all that kind of stuff. And so I just told him, like, I really don't, I haven't been in that field in a very long time.
Yeah.
Like 14 years. So I really had no idea what was going on in the world in regards to anti-gravity, which was one of my things I was interested in when I was a teenager. Was it called the lifter devices?
Okay.
Yeah, it was interesting because those were just kind of coming out then. After that conversation with him, I decided, like, I'm going to go on the internet and just find out what's going on in the world with anti-gravity and free energy and all that genre. And soon after, I think it was that night, so it was 2007, I found John Searl had come out recently, and Fernando had made the first version mock-up.
Oh, okay. I remember that video. I remember when that came out.
Yeah, the very first one. And I think he was still in Britain at that moment, but Fernando was showing him the model they made, the mock-up, and it really caught my attention. I thought I could probably build that, and it would be fairly simple to build that mock-up. And that was, starting at that point, that was my real intention, was to just copy the mock-up and make the mock-up. But as I got into it, from January 8th of 2008 is when that journey started.
Okay.
And quite a while ago, I have vastly surpassed that goal of mine.
Yeah, I would say you have too.
Yeah, quite a while ago.
I think you're the #1 builder in the world for SEG stuff.
As far as I know, yeah.
And your journey is probably just beginning, right? The SEG is one aspect of it, but we've talked over the last couple of days about other projects that you're considering now. So
yes.
That's kind of where it starts. It's interesting because my story is somewhat similar. For me, it was Bill Butler's HoverTech back in 1992. He had a classified ad in the back of Popular Science.
I remember that ad.
Yeah.
Yes, I remember that.
Yeah, and it was like, build your own hoverboard, buy the plans.
Yes.
And I guess disclaimer, it does not work as advertised, but that's okay because the attempt was what got me going.
It's a hoverboard, HoverTech, yeah.
Yeah, and it's like, okay, if you buy this and you put these pieces together, it will work. Okay, so I did it and it didn't work. I was like, well, what did I miss? So then I started studying at college libraries. I started going in, like the Western Washington University Library. They had this enormous engineering department. I just haunted that place for a couple of years. I'd do my college classes, and then I would just spend like 3 or 4 hours there with my bag full of quarters for the photocopier, So yeah, same kind of deal, right? You get bit by the bug.
Yeah.
You're like, okay, that's it. So
that's kind of how it was. I mean, I never started into this thinking it would lead to this. I never really had a goal. It's just kind of a fun little side project that I was building. But at that time in that season, I had no idea what I was doing, and I certainly never thought I would probably get to this point.
One of the great things about this is, like you, like myself, like everyone else, was raised on science fiction. Our culture raised a couple of generations of young men on sci-fi, on space, on rockets, on all of these adventures, and then basically said to us, you have to wait for NASA to do this.
Yeah.
This you can do yourself, and you are doing yourself, right? Correct. So it's not only a creative outlet, not only kind of an artistic outlet in some ways, but it's also a way to kind of take action and say, look, I want to make this dream a reality, and here's what I can do.
Yes. Yeah, and as this has grown, over from, I think this is the 6th iteration, which I already have plans for, I think an 8th or a 9th iteration already.
Okay.
Next is version 7. Obviously, this is version 6. But that's the thing, is it's just learning each iteration, each step I make is like a building platform for the next step to the next step to the next step. So it really has been a labor of love, but with each thing I learn, it's more emotional fuel to go to the next step, because it's kind of like this thing of like, what more am I going to discover? How many more trails is this going to pull me in towards? And now with this stuff, is kind of, I'm finding more things, more trails, like, well, not parallel paths, Floyd Suite, and how this kind of AC waveform in magnets has really been around for, from what I can find, about 103 years or so.
So it goes back a ways then.
To the Nazi scientists. Yeah.
Okay.
A ways back. It's gone way back into history.
It's interesting, though, that the SEG has become your baby.
Yeah.
And like one example that comes to mind is Mark Sokol with his dynamic nuclear polarization. He has tried so many different projects. He's had his hand in so many different pots, and yet that's the one that he comes back to, right? And I think that's a good thing. That's a really exciting project with a lot of possibilities. But the part that gets me is, what is it about that project? With the SEG, this one is yours. This is your baby. What is it about the SEG specifically? Or do you know? Maybe you don't know.
I think it's a combination of a lot of things. For me, emotionally, I think it's the hope to see it completed. That's what's kind of gotten me through of continuing this project for now. It's over 17 and a half years now I've been on this.
Okay.
The real big discovery was, I don't remember the exact date this year, but it ended up being on the day, it was sometime in January. Again, it was 17 years, 21 days. I found from the day I started till that day was when I found I could do magnetic imprinting. That was a major leap forward. I mean, every thing I've discovered up until that point was good, but that was just like leap and bounds more. Like, now I can condition magnets. Now I can start putting patterns on that I want to do. And the latest point up to that was just putting slots into the magnets. That was, for me, that was a massive game changer.
Yeah.
Massive.
Well, and again, the sky is kind of the limit, right? You're talking about putting multiple rings and roller systems together, and and then you're also looking at like the half-scale unit so that you can do this more cost-effectively and then scale things up.
Yeah, and then basically put it in a nice carry case and take it to places and show people. That's the full 3-ring system with all the rollers, the inductors, the drivers, everything. I want to do something that's totally portable.
And what I heard earlier was, as you were learning about the SEG and this, I mean, Searl had decades of marketing within the community, right? That's all you could call it. I mean, he had books and tapes and movies, and he did have photos and his share of controversies and drama. There was so much behind that. This was one of the cornerstones of classic, anti-gravity research.
Oh, yeah.
Right? And so, yeah, to read about that, to see Fernando's device in 2007, then there is this idea of, okay, it's been hanging out there. If I could complete that, yeah, that would seem like a big motivation.
Yes. Yeah, and in a limited fashion, they were able to help me with some basic design questions I had. Primarily, Fernando contributed with giving me the circuits to drive the first unit, which that was just a stepping stone. Eventually, I had problems with that. They would overheat. The rollers could only do a certain speed before they would start to levitate off the surface and smack the electromagnets. A lot of problems. So it was just like, how do I go past this? And the ultimate goal is, I keep saying this, believing that eventually I'll get to that, is the rollers drive themselves instead of this undercarriage that drives it now.
Yeah.
Eventually it's just somehow, I can imagine, I can see it in my mind. I could see this before I built it, doing something like that. But eventually that's the point I want to get, is somehow there has to be a way these rollers excite themselves and push themselves around the perimeter.
Well, I think you'll get there. I think the undercarriage is a brilliant workaround because it lets you basically provide that motive power to it without having to change the design itself.
Correct.
Right? You're able to work around that design, you know? And then these coils up on top, instead of being what moves it, now you can use these as energy pickups.
Correct. Yeah, and also the thing is, essentially, if this was a full running mechanism, this is kind of how it would probably look, with inductors around collecting the excess electrons, and obviously a full scale you would have the 3 rings. It would be a little bit bigger, but it's kind of the idea that no one else has ever put this together. I've heard Searl did this to run his house, but there's 0 pictures of that unit. None. The people that confiscated it, apparently they were the ones who saw it, they took it apart, but you kind of just have their word of the whole thing, and they're long since passed away.
Yeah.
0 pictures.
Yeah, it's become like this legend, right?
It is a legend, yeah.
Yeah, and so, yeah, again, that seems like total motivation, because now you're able to complete that legend and bring it back to life.
Yeah.
But then you're also preserving history, and for me, that's really exciting, because to see these things come and go and then get lost, right? And the real tragedy would be someone coming back to this in 400 or 500 years and saying, "Oh my God, there's something here. You know, I wish we hadn't ignored this." Right? Like Leonardo da Vinci inventing the helicopter 500 years ago. Okay, it wasn't perfect, but he had a really good idea. If they had paid attention to it back then, who knows how things might have changed.
And quickly too. And he had the framework for it. He didn't have all the fine details like we have today, but he had the basic concept and framework. Ideally, I mean, in a future time from now that I probably won't be here, but if they have molecular engineering, this would be a cakewalk to build. Because right at the molecular level, you could build the sucker. And those questions we had of things we don't, I mean, for a person like me, I don't have the technological ability at the molecular level to build it. They would sometime in the future. And I've had dreams about that too, of just building things from the molecules up. You could program the magnets exactly how you would want, the way I dreamed to do it.
Well, you made an analogy earlier that stuck in my head, and I really like this. I've never thought of the Searl Effect Generator like this before, but you'd said that the ring and roller system is the hardware and the magnetization of it is the software.
Correct.
And I love that idea because, again, when you look at this, and most people do, they look at the physical construction of it and they say, okay, here's what I think it could do, should do, or can't possibly do. What they're ignoring is the fact that it has these incredibly complex fields embedded in it, right?
Correct.
That can't be seen unless you're using special equipment.
Correct. Yeah. And that's what boggles my mind about the Russian one, is they didn't have any complex fields. They just had magnets going up and then sprockets, but yet they got unusual effects. So, but they still had some cross symmetry with perpendicular magnets. It wasn't just regular household magnets. Those don't do anything. I haven't seen any replica of those doing anything abnormal. Mr. Delphin's had his own unique blend of special magnetizing on his rollers, and even this, he just had triangular pieces of magnets going like this for his stator. But it did some unique, I mean, his stator, or the neodymium cooled off in seconds. So there was some unique magnetization patterns. But I'm hoping, for lack of a better word, I'm hoping that with trying to stick very close to John Searl's designs and his parameters, the things he left us, and putting a unique magnetic patterns onto these magnets, and then also at some point using a real rare earth center, getting some very anomalous results.
Okay.
Hopefully.
And then you had talked about building another ring as well. Do you have like an estimated time for that?
I don't. Simply because I'm focusing right now on getting these magnetization on the roller rings exactly how I want it. Basically, when I get to the point where I have the bump, which I already have that, basically the spike and then the 136 points on it, and I can have it so when it goes up to this, it'll just oscillate. The field itself is oscillating.
Okay.
It grabs it. Then I know I have that system down. I'll magnetize all the roller rings all that way, and then move to the stator magnets.
Ah, okay.
So it's like perfecting this, or perfecting is the right word, getting to the point I'm satisfied with it. With the magnetization, I know it's good enough, it'll do, and then moving on from that into the stator magnets.
That's fair. You're not rushing it. That's what you're saying. The other thing that you're doing, and I'm just putting this out there, like as a friend, but also someone who's been covering this, one of the things that I love about your work is you were doing open, honest work, right? And again, in this community, traditionally, you know, half the stuff is secret sauce, and the other half, you're not sure if you can trust the people saying it. And in your case, you're just like, look, here's what I built, here's how it works. You know, you can see underneath it, you can see above it, here's what it does, and here are the things that I don't understand, right?
A lot of things I don't understand, or how to get, you know, continue it, but it's, I guess from my experience, it's been like make 20 or 30 mistakes, and then in that mix, you find out, okay, those don't work, but this one thing kind of had some results, and focus on that one until I get it really, really working. But I've also had the experience where, like 14 years ago, I did this, and it kind of gave some results, and so that's what I brought back of like putting the groove lines into the ring magnet. Oh, I got these beautiful patterns. What can I do instead of doing groove lines? Oh, do it magnetically. So 14 years ago, I dropped that. I dropped it, did nothing with it, but I kept remembering that.
Yeah.
So I brought it back last year, tweaked with it, tweaked with it, tweaked with it, and now it resulted in me all to magnetically condition them.
Has working on this made you more of a believer or less? And the reason I ask that is you mentioned seeing lots and lots of little indicators of things that weren't obvious, right? Searl would predict this and then you saw it. Searl would predict that and then you saw it. You know, are you becoming more of a believer in the reality of this legend, I guess?
Yes, I would have to answer that was yes. And the more I get into it, the more there's a few points on this system that I still have questions about. But the more I work with it, and even like recently was this, the spinning, the oscillating is another thing Searl would say is when it would spin, you would continue to spin even when they're levitating without touching. So that was another indicator. And anybody out there who says you can't put sine waves onto magnets, I haven't met those people. I've heard a lot, oh, scientists say you can't do that. Well, I haven't met one or even heard one say you can't. But I know for a fact I can repeat it, and I can give them the plans that they want to try themselves, and you can put sine waves onto magnets. It's easy. It's not difficult. AC sine waves, I don't know how to do that yet. The one big conundrum I'm facing with this thing is Searl said that he could get up to, you know, ridiculously high speeds without the rollers flying off. The best speed I've ever been able to get is 498 RPM sustained. A little bit over that, the roller would fly off, and that was when I was using N55 magnets on these with no sleeves and no insides, just bare magnet around this perimeter. I could do 498 RPM.
But was he talking about a multi-ring roller system? Did it have something to constrain those?
So probably yes.
Okay, so that might be the speed limit right there, right?
It could be. And something I've also figured out, not experimentally but mathematically, is the larger the ring, the faster the roller can go. Because when you're working with these real tight systems, they're making these fast turns, but when you get into these wider orbits, the turn rate is, you know, it's not like that.
Oh, the
radius is much wider, and so you could be going a lot faster. So that's something experimentally I have to try. By looking at my math and my own intuition, I feel like you can get higher and higher RPMs the wider it goes, because the degree of turn is much less. So it's almost like you're shooting that roller across a flat plane almost.
Do you feel like you're seeing in the onset of any anomalous effects? Again, you did see a couple of things that I thought were interesting are the centrifugal force wants to pull those rollers off it, so there's less friction as you get it up to speed.
Correct.
So it begins to run very quietly. That's something I heard when you did demos for me. And I was really excited by that. I was like, wow, once this thing gets going and it gets moving, it starts to quiet down. It starts to be more stable. Another thing that you saw with the temperature probe was some mild cooling, right? And again, these things are supposed to run cold. Do you think that you might be seeing the onset of some of these anomalous features that are part of this story?
So today we witnessed like one drop in temperature on the copper. Mr. Delphin, I can only draw from his videos because he's the only one I visually have seen drop temperature. He saw the same results on his first few models before he used neodymium. His dropped about 1 or 2 degrees on his temperature probe, and he was like, I think it's just the wind. And he was like, is this the Searl effect? It's 1 or 2 degrees. I mean, these things produce a little bit of wind outward that way. And he didn't have much else happening at all. And he could get up to about 500 to 600 RPM, but his was flipped. Like his copper layer was out here and the rollers circulating on the inside pushing outwards. So he could do higher RPM up to a certain point, and at a certain RPM range, the roller would just fly out. And that was the end of it.
Okay.
So he had his limits with that.
But one of his limits, it sounds like, is, again, because centrifugal force is trying to pull yours off, so you are able to get it to run with less friction and quietly,
yes,
right?
Less friction. His would have more because it's pushing against the copper, as mine's pulling away. And I have found that balancing points with these, like this roller and this roller particularly. I can get about 385 RPM sustained without flying off. 396, it's gone. But the sound at about 350, the sound does drop some. But the only problem is I only have one of these rollers. I'm sparing these magnets because I have a limited supply. I don't want to use the other ones up. I want to save them to put the final imprints on.
From what you showed me earlier, the neodymium magnets seem like they are similar to the lesser grade that you used, right? Because you were asking what is the difference between those. What I saw was the neodymium is just a better material. It's more magnetic. It produces and retains more of a field.
Oh,
right?
yeah.
So it wouldn't be surprising that if you're not using those, as some of these other experiments were, you might still see some effects, right? Again, just not as pronounced.
Yes. And Delphin was using neodymium magnets too. His were strange. Like his magnets were this part, and then he had a magnetic material again. So he had like 2 layers with an insulator, and then so I think he had neodymium magnet and then insulator and then ferrite and then a copper jacket or aluminum. He did a lot of different variables, but his fields were square shaped, kind of like one of the ones I showed earlier. He had square shaped fields in there, and then he had angled fields here. So it was very odd, but yet he got results.
Interesting. Yeah, this is, again, historically speaking, you're making history, but it's also historically amazing. You're bringing history to life.
Yeah.
Right? I mean, yeah, I first read about Searl back in the 90s, and I saw that video. He had a couple of really long videos online, right? And, just looking at this, there's this part of me that's like, oh my God, it's real. It's real. Yeah.
And that's kind of the choice of my materials, even for this base. This phenolic board has been around for a long time, and eventually I'll do a version, probably this one, where I want to do it as if I was there in the 1946 when he built the first unit. How would that look? Well, they had cloth wiring. They had kind of cloth type tape. They still had magnet wire, but they had more Bakelite instead of plastic. So I wanted the look. That one will probably never end up doing anything except look like an original 1940s. I mean, the Frankenstein style switch, I'll use that. And I'll probably have a drive motor if anything, but authentic. Like if I was there in 1946 at that factory when he built it, how would they put it together? He probably had a piece of old plywood he put it on. So I might do something like that.
Yeah.
Only on that model. But just like trying to envision like how he really built that very, very first model, do something like that. But obviously with these version 7, it will probably be something like, I might use this very platform to do that.
Well, so moving over to Floyd Suite,
Yeah.
that was something that you kind of surprised me with. You've been studying up on Floyd Suite. That's something I'm a little bit familiar with through Tom Bearden. I talked to Tom Bearden several times, and this was back in the day when I was into gravity stuff, and every time I asked him about it, he always pointed me back to Floyd Suite's vacuum triode amplifier. And so when you mentioned that, I was kind of surprised. I thought, wow, that's interesting. You're thinking that it might actually be like a solid state version of the SEG.
Pretty much. I haven't been studying Floyd maybe the last 3 months, so I only have 3 months of research onto his project. Not almost 18 years like this, but with everything I've learned about this, listening to Floyd Suite, it's like they're two parallel paths. Searl's was a mechanical moving thing, as where Floyd's is just solid state. The secret is in the cake mix, so to say, in the ingredients. But Floyd was putting 60 hertz frequency waves into a flat brick magnet, and he would excite that field by putting a tiny little bit of trickle current into an exciter coil, and it would build up a potential. So the output, you have an input coil, an output coil, and an exciter coil. So you put a little bit of input, and then you use that trigger coil and have a massive output.
Okay.
Apparently, what I've learned is the unit would get cold, it would have anti-gravitic effects, kind of like this one. It would get cold, it would fly, but no moving parts. The only moving was the electron flow through there. But it would, just like this, it would use thermal as basically its energy source. It was not a closed system, it was an open source.
But it's using magnetic fields.
Using magnetic fields to harvest energy out of the environment and then just trigger that, and so its output was greater. So it did have a fuel, you could say a fuel source. It was thermal, mostly thermal, maybe background radiation too. There is a source it's taking its energy from.
Yeah.
It's just, in my mind, it's like a waveguide, or it's channeling giving the environment a way to channel energy into it and tapping that source. But with Floyd stuff, the more I've learned about his, basically homemade DIY, bare bones. If he taught, you could teach a high schooler how to do it, if taught correctly. He used his kitchen toaster oven to condition his magnets, to heat them up, and then put them in like a bucket with coils around it, hooked up to signal generators and a few like low grade or low power amplifiers. Nothing like multi-million-dollar equipment. You're talking like stuff you could just buy almost anywhere, really.
Well, and we're looking at this through the lens of like the 21st century, right?
Yeah.
And part of that is like 50 years of, rigorous, super expensive, team-based, project management-led science. But again, back in like the 40s through the 60s, you had all these electrical experimenter handbooks, and young men, boys, would read these things, and they'd be like, I can build this, and I can do it with, conditioning magnets in my oven, right?
Yeah. I've got one of those books. Bandini recommended it, so I went and bought it, and it's 1920s, 1930s, 1940s, old school technology.
Yeah, I love it. Yeah.
And it talks about all that basic stuff.
Yeah, no, those are so exciting, and it's inspiring. It's led you to this. So from Floyd Suite stuff, do you have any ideas that you can apply to the SEG, or are you not kind of at that point yet?
The one thing I took away immediately was finding the resonance points on magnets. That's something which I believe right now it would be a huge help to know that, okay, is this process I'm doing actually changing the resonance point on a magnet? Is it actually doing anything at all? From what I ascertained yesterday and today, it does cause a shift in Hertz response.
Okay.
So that's a great indicator. Before, basically, I had no information at all to do such a thing. I didn't even think to do such a thing. But now actually I can actually take a magnet, and after my process and tune it and working on it, I can see if that Hertz response is in that magnet or not. So that is a great assist to me. And the other thing he did was using just a simple signal generator to put those wave fields into a magnet. I didn't think my equipment could even hope to do that, but he was doing it with, I don't know, great ease, but it wasn't like, you know, $100,000 worth of equipment. It was just stuff he had in his garage.
Well, and the other thing about that caught me when you were describing it earlier, and it reminded me of Tom Bearden's Meg, right, was this idea of a magnetic circuit where you're actually changing the path, you're switching the path of a magnetic field inside of a material. And I've heard the Meg explained as basically a magnetic transistor because of that, right? And what you're talking about with Floyd Suite's VTA sounds similar.
Yeah. And that was one thing that caught me is I think it might have been Tom Bearden or Bendini talked about it, is using high voltage to treat the magnets, which Searl mentioned once or twice. It was just hardly ever mentioned. To treat the magnets as dielectrics and also putting the patterns on, treat them as dielectrics. But something I've never heard in any literature is that AC waveform is able to switch around.
Yeah, you mentioned that earlier, and that contributed to my thought.
Yeah.
And again, for me, this is all new. As someone who's read about the SEG for decades, like what you're mentioning now is new, and I'm like making connections in my mind and going, oh, okay, so not only are you're doing magnetic conditioning on it, you're imprinting a waveform onto the actual magnets, but you can actually change the way the magnetic field goes through those magnets as it operates. I'm like, This is really a whole new world. Again, it's simple on the surface, it looks very basic, but then what it's being used for and the way that it's conditioned is so much more complex. That's remarkable.
Yes, and that was the one thing that always got me is like, how can a hard material be switching poles?
Yeah.
I don't understand that. I haven't witnessed it yet, but I'm going to try until I realize either it works or it doesn't. But that makes sense to me because without something fluxing and changing, you don't get any kind of movement. You don't get current moving. But if something's switching back and forth, then things move. Current begins to develop because it's moving back and forth inside of a hardened material. So if Floyd was able to do that in his magnets, I'm believing that probably in a similar case, Searl had to do that with his rollers, and that's why they do it. Just he would put them on and they would just move by themselves.
Well, and the layering, and I think Searl may have said this himself, if not, someone else did. The layering is somewhat like a transistor, right? And like that is also a solid state device.
Yes,
it's just a chunk of material, right? Silicon, germanium, something like that. And the way that you apply the voltage to it allows it to conduct more or less, right?
A gate.
A gate.
And that's what he calls it, a gate.
Yeah. Yeah. So it is interesting because you have, again, it's deceptively simple, right? He's like, put these materials in this order, put the rollers on like this, and people think, oh, if I do it like that, it's going to be magic. But there's this whole like underbelly to it, a whole series of things that you have to do and test and understand. And you're undertaking that. That's amazing.
Yeah, it's really fascinating to read the older books. I remember one was called the Ether Engines or Ether Electricity or something, but it was an old book written in the 70s. He talked a lot about Searl, but he had no idea what the layers were.
Okay.
And he's like, they're cylindrical rings within cylindrical rings within cylindrical rings. Somehow Searl has energized them to be able to make them move. I mean, it's funny reading like, well, yeah, that makes sense now because I know what each one is composed of and the magnetic material and the imprinting. But back then, it just seemed like magic. Like it's just rings, but it's not just rings. It's like, yeah, this one's simple, this one's simple, this one's simple. That one has all the program on it, all the software.
Yeah.
That's what gives it its spark, its life.
Well, and in addition to being kind of a transistor, it's also a linear motor, right?
Yeah, a linear motor.
And it seems related in some ways to the homopolar motor, which is a relativistic motor. So there's a lot going on there. And one of the things that I've wondered is with multiple rings, maybe it's kind of a relativistic motor inside of a relativistic motor, right? I mean, it just gets more and more complicated.
Yeah, and I think as you add those multiple ring layers, the second and third one, that's what Searl said, is you won't really notice the levitating effect until you get those multiple rings, and then it really becomes pronounced. and that's what Fernando has stated based only on what Searl has said. I have yet to see that because I haven't built a second ring, a functioning second ring.
Yeah.
So that will come in time.
The thing that interests me about that is it seems like when you have multiple rings and rotors and you don't see an effect and then you start to see anti-gravity, that reminds me of what I've read about torsion physics and non-linear physical effects, right? And especially in terms of these anomalies, you see a little bit of this and a little bit of that, and it's hard to detect, and then it goes from that to something really pronounced really rapidly.
Yeah.
Right? So
what I've Searl, I mean, this is kind of just his word of mouth, but and one eyewitness when they were a child is when he had the 3-ring system out in a field. It took him hours to be able to get that thing from just circling around to where it just shot off and gone forever. But I think it had to do with the driver units he was using to get the rollers to spin up, and he said he used electromagnets, like a coil of wire around driven by a diesel generator. I used to think it was always coupled, somehow mechanically coupled to these, and it wasn't. It was some sort of coil arrangement, and he would use frequencies on those coils going around the rollers to get them to just move.
okay.
So it was some sort of an induction type.
So he was priming it like a linear motor. He was starting to move it, and then once it reached a certain speed, then it would begin to do that classic Searl effect self-spin.
Self-spin, yeah. But it took him hours to get that just right to where they would even start to move. But once they started to move, he could speed them up, and then once it sped up, it was gone for good.
You've seen similar things tuning this, though, right? It takes a long time to reach that sweet spot for different aspects of this.
Mm-hmm. And then there's also certain speeds it likes, and some that seem to be harmonious, and others it doesn't like a certain speed. I'm not exactly why that is. I suspect that once all the rollers are on here, they're all exactly identical. I'll probably find harmonics of speeds that it likes, and others it doesn't seem to spin just as right. You can hear like a bad oscillation, and then when you hit a certain other speed, it's real smooth.
Now, one thing I've wondered about, I was asking about like speeds earlier, and you said you were unsure about that. I had heard Searl say something about the SEG will meet any load.
Yeah.
And so once you get the coil taps in place and you're able to draw energy from it effectively, there's this thought that occurred to me, maybe the speed depends on the external load.
It will speed up to meet that load.
Yeah, whatever that hypothetically might be.
Yeah. I remember he talked about his first unit. He hooked up like his crockpot cooker to it. I mean, kind of like higher amperage thing. And it met that, and then it just continued to just speed up to meet the load. And he hooked up lights and stuff, and it continued to speed up to meet that load. The faster, it would go faster and faster to meet that load.
So that would be, yeah, so that might be a positive answer to that question then. Yeah, mm-hmm. It sounds like it's, the speed depends on what you're driving with it.
Correct.
And if I remember correctly, if you're driving it past a certain point, that's where you get the gravitic effects.
Yeah, the cooling really kicks in, like the cooling dramatically goes down, and they said it was like 4 Kelvin. How would they measure that? I don't know. Like, it was just a nice guess. But Searl said he touched it and his hand froze to it, so that's got to be dang cold if his hand froze to it. Delphins, all I can speak is Delphins. I've seen it and spoken to the guy, and his went pretty dang cold. It was negative 17.5 C. So it was way below freezing.
That's cold.
That's cold.
That is cold.
Yeah.
Do you have any idea what speed he was running it at?
I think 420 RPM. So I can't quite get to that speed with my setup. I can do 385, but I did see in his video, even when he started up after 200 RPM, the temperature started lowering.
Now, have you been able to work with Delphin at all?
He's gone. After his final video was made, within about 2 to 4 months,
he passed.
Well, I think he's just gone quiet. Because in one of his last videos, he said he was packing the device up and said it's going to a lab for more testing. And he did one video about a roller with a light in it, and that has been it. His email is gone. All references to him is gone. Okay. I'm believing he's somewhere out there working on it, somewhere in the world.
Possibly. Yeah.
That's what
but
I
at
suspect.
least he's still with us, right? I mean, John
believe
Searle
so.
and innumerable number of other researchers and scientists have passed. And again, that makes the history and it makes preserving this so much more important, right?
Yeah.
I mean, just today, I'm not going to get into details, but just today we learned about someone else close to both of us who passed.
Yeah.
You know?
It's very sad.
And to me, the way that I look at that is this technology is the product of another time. And the people who really specialized in it came out of that time, and we're blessed that some of them are still with us, but we're losing them rapidly. Right?
Yeah, this was almost started, well, we're coming up on almost 79 years ago, 80 years ago, pretty close. It was a long time ago that this was first created.
Yeah. And then part of it is how long will it take to complete? And I think the answer to that, because we're all itchy for it, is the answer to that is not measured in time. I think it's measured in work, and you're doing the work,
Correct.
right? And the reason that I say that is like the Greeks invented the steam engine, you know? The Chinese invented fireworks 2,000 years ago or something. Okay, those sat there, or they were used for a tiny little application until someone came along and said, we can do this with it, and here's why it matters, and we're going to build it, right?
Right.
And so then what starts out as fireworks to entertain children becomes the cannon, you know?
And firearms and rockets and...
Yeah, and then it takes off, quite literally. It takes off. You know?
Correct.
Yeah, so all of these things, it's not measurable in time, it's measurable in work. And by moving it forward like this, especially, again, thank you so much for sharing details of
You're
this.
welcome.
You know?
Absolutely.
I mean,
welcome.
being open, taking like an honest, integrity-based approach to it, sharing what you know, what you don't know, all of those things. I mean, not only does that showcase your hard work and expertise, but it also helps engage other people, you know? And somewhere out there, there's that kid who's just like you or I was, right? 20, 30 years ago. And hopefully he'll watch this and say, I want to build one of those, but he won't have to start from scratch.
No, I got 18 years of information to give you.
Yeah.
Yeah, that was essentially like, I mean, he's not a kid anymore, but Josh Varner, I mean, he came into this and I had 17 years at that point of information to just dump on him, and he took it and ran with it. And he's doing great with his research. But aside from him, maybe one or two others, you know, I have all this information. I'm happy to give it away if I see the person actually would want to do something with it. It's not I just want to put it on the internet, but if somebody is actually genuinely interested, it'll be very easy to see that they want to follow up. I'm happy to give information to them.
Who are some of the other folks that you are working with? Who are the folks that you want to work with on this?
Boy, that's a question I haven't really thought of.
And I don't mean specific people. I mean, like, in terms of people who want to get involved, right? I mean, obviously, we want to focus on trying to get you collaborative relationships with people who can help move this forward for you and for them. But in terms of forming a working group and collaborating with others, you know, I mean, what have you thought about that?
From what I've seen already, it's people generally about my age group. And I have an online team that you're part of on that conversation, the messaging. There's another guy, his name is Ryan, and then we have Josh and Jared and me and you. That's really the core group. There's another guy on there, but we haven't heard from him in a while. He's just been busy. But really, that's kind of the core group I have of just like-minded individuals. And I would say, you know, every single one of them has a far more greater understanding of physics and electronics than I do. I've been relentless in this.
Yeah.
And I just don't give up.
Well, no, I think that's amazing. Yeah, you have incredible tenacity. It's like, yeah, you've dug in and just, you know, and again, you're doing the work. Now, one thing that's interesting to me is to see these different groups of people who are specializing in different passion projects, right? Like, again, Glenn Tony Robertson, he has gone back to working with superconductors. He's putting together a working group for that. You know, Mark Sokol has a working group for his dynamic nuclear polarization. And so even in this community, you have different groups of people who are focused on the thing that grabs them for whatever reason, you know? And that for you, it's the Searl effect. But I think one of the advantages that you may have is the knowledge of this reached so far. There are probably a lot of people out there to draw from.
There are, and that's a very good question you asked about what if I could have, more people come in on this or assist me, I think is what you asked. I really haven't given that much thought, but it's not just, I never ask for money on this. That's one of my things. If people offer it, I would want to use it, but I really am looking for people with more understanding than I've gleaned, and like electronics and magnetism. That's really what I want to be after, is people with, if they understand how to create magnets and fabricate them, that would be a huge assistant.
Okay.
Machining skills is great, but somebody I've yet to meet would be somebody who understands magnetizing materials. The only people I know how to do that, there's an outfit in Clackamas who know the real basics about, basically charge it up, push a button, which I understand that. The people in China who do magnetizing all the time, they understand magnets, but not quite the way I'm going at it. I'm going from a whole different type of engineering skill set, but a whole different branch of magnetism, as where they're just used to charging them up, pushing a button, setting the voltage right. They do it as a factory worker.
Yeah, no, I get what you're saying. Traditional charging magnets. It's just like, okay, North Pole, South Pole, here's the intensity we hit it with, here's the result.
Right. And that's not what this is. This is, I want to hit 136 points of magnetism, AC and DC at the same time.
Yeah, and so...
Non-traditional.
Now, for a way that I could be mistaken, but the way that I would explain that to like someone from a more traditional background, I guess, would be when you talk about putting a signal on a magnet, really what you're talking about is putting a series of positive and negative magnetic areas on the magnet so that when it rotates, it creates a signal.
Yes,
so
when it rotates.
And you mentioned earlier physicists saying it's not possible in this or that way. I think part of the issue might just be communication, right? It's like, okay, can you put the signal on it? No, I get it, but here's what we're doing that produces a signal when it is in operation.
Yes.
So
my thought on that was like, well, we have magnetic tapes, and you can listen to music on magnetic tapes.
Exactly.
And that's magnetic material, although extremely thin. You can still program it to do that, even though it's darn thin. This is much thicker. So with the right understanding and the right experimentation, why couldn't I do it on a thicker substrate? I'm not trying to put music, in a sense. I'm just trying to put pulses.
Yeah, and now that you put that idea in my head, I'm thinking, what could you use those for? Old computer tapes or something. It's like, could you use those in this project somehow?
I've thought that too. Like if I want enough thick enough layer, could it actually be used in here so that each wrap corresponds to the one prior?
Yeah, because you have a very predictable magnetic material. It's isolated by plastic on both sides, right?
Yeah.
So, it's not the strongest signal, but again, towards the end of the cassette tape era, they were doing some pretty interesting stuff too. So.
Yeah. I have heard rumors, only rumors, there have been some people who basically took the idea of a magnetic recording track head, which is basically just a very small coil of wire with a loop of iron with a slot in it that the tape passes through.
Okay.
And they've made a big one, and we're able to put AC signals and then magnetize magnets like this and put signals into them. I don't know who they were. I only read one document and somebody said they could do that back in the 80s or something.
Well, and one of the things, and this comes from the device that you were rotating behind you when you had wobble on it, right?
Yeah, wobble.
And so embedding that signal into the magnet itself means that it will catch. That's the magnetic gear.
Correct.
Right? And that's what differentiates it from just being a roller. If it's just a roller, you may not have the linear motion come out of it. But if it's got teeth, which is what you're putting into these, you've created a magnetic gear.
Yeah. Yeah, and you all could see that when that thing would oscillate. So what I'm getting after is that the field will oscillate, but the magnet stays straight.
Exactly. Yeah.
So that this can grab hold of it.
Exactly. Yeah. And that was what I noticed earlier was, when it was physically oscillating, right? And so you want to reproduce that physical oscillation without the instability. So then you just imprint the field in it, and then when it rotates underneath, it grabs it.
exactly.
Right? And you mentioned, I think, a 21-degree angle on the magnetization.
21
as well.
degrees. Yeah, 21 degrees, 8 layers, 34 points, creates that 180-degree twist. That's what I'm, one of the byproducts that no one ever mentioned before until I actually physically built the model and saw it. It was like, well, that's crazy math. That's interesting.
Now, in terms of future work, you had talked about replacing these with rare earths that someone found. And so you've already got some things in the works in terms of like material substitution. The ring is not nylon 66. This white ring is Teflon, if I remember correctly, right? And so you're trying to update and modernize this. And again, I know it's touchy because you want to stay pure to Searl's work.
Yeah.
And one of the reasons is folks like Godin and Roshan, they changed the formula, and so if it doesn't work, you can't blame them, right? It's like, well, hey, you changed the cake mix.
Dramatically
it didn't make the way it's
different.
supposed to. Yeah, but then at the other end of things, you want to make it more durable, you want to make it function better, more cost effective, and these materials are easier to obtain and work with and things like that, right?
Yes.
You mentioned 3D printing some of these parts.
Yeah, so there's two options for this. Searl says you can use nylon 66, and Fernando says you can use Teflon because they're both, the gram weight will work. So you cannot print 3D, you cannot 3D print Teflon, but nylon 66 you can. So that is one of the options we now have, is we can 3D print our insulators, or our dielectric insulators.
Okay, so that simplifies it a little bit.
Oh, tremendously, because I mean, it is quite the process to be able to machine this out just right. And then each single roller segment, machining them out. These I bought all from China. I had them prefabbed in China and sent to me. A few $100 for all 96 or all 100 pieces. It was wonderful. It was so easy. I just gave them the specs, and they machined them all out of Teflon and sent them back.
Oh, the Teflon rings, you mean?
For these.
Now, what about the copper?
So the copper, for all future rollers, I've had the same company that made the Teflon rings in China. They will make my copper jackets. Perfect. And they're all within maybe 0.2 of a gram accuracy. I've weighed them, and they're just nearly dead on accurate.
Okay, and so how much do the rollers typically cost?
Let's see. So each magnetic ring is about $5. Each one of these, well, I don't know about the neodymium yet, but for these they were about 99 cents for the blank magnets.
Okay.
And then for the Teflon, I think they were about $1.30 for each piece of Teflon. And the copper, I think it was about $3 or $4 or $5 or something.
So it adds up, but it's not insane.
It's
right?
not insane.
Yeah.
This is a bit much on the pricey side. When I first got it, they charged me $600, but that was their very first trial run. And after now, they're saying they want about $1,200 for the one layer. These are about $700, $800 for all 6. This is about, how much? About $200 for the block. This was about 3 years ago. This was about $800.
And I'm going to cause trouble by asking this, but like, do you think it might be possible to 3D print something to replace the copper if you had a conductive plastic?
I have thought about that. Probably not, because I need it to be copper 101. This one here is actually copper 110.
Ah, okay.
And I love it, but there are slight differences. Even like that former one over there, that's copper 101, and this is copper 110. So there's a little bit more alloy type material in this. And I noticed the difference is this one gets, when it oxidizes, like when I don't use it, this has a little bit more of a red color, as where that gets more of the copper orange.
Okay.
So there is a very minor difference. And what Fernando and Searl state is it really needs to be that pure grade, high electrical conductivity, copper 101.
Oh, okay.
Yeah. And the manufacturer I hired in China cannot source that.
Could you use another metal? I mean, the only metal I know of is silver with a higher conductivity, and that would be even worse to work with. But
the option I have now is that manufacturers here in the United States can do it locally here. So I'm going to go back to what I was using, which was that one actually right there, this nice shiny one. That's copper 101. So I'm going back to, I have three manufacturers here right locally to me, and they can do these bands.
Oh, interesting. Yeah, and then you have a band on that.
That was
a band there.
one of the very first ones they ever made, which has a floppy air. But that was, I think, around 14 years ago they made this one. I've kept it and I shined it back up.
Oh, okay, I see.
Yeah, so there's a little bit of an error on it right there.
So it's useful for testing, but yeah, you wouldn't want to try and produce anything with it.
Correct. The rollers would treat that like a launching point. A little bump. No, that's bad.
Yeah, I was just, one of the things that I wondered about was you have these rollers of different diameters, right? And like you can scale it out for multiple rings. You could also scale it in, right? Have you thought about trying to put an interior ring in there for any of these? You talked about a core. What if you tried putting a smaller ring in the middle?
I honestly...
For this one, probably not, right?
No, it's too small.
Yeah, but if you had a ring to work with, maybe. I mean,
it is... If you scale it down, kind of like that Halfscale model is going to do that. I've honestly had that thought with this system, just because these are all proportional for the right sizes, and that is all relative to the weight of the center. You start with this center, and then mathematically you just work out, and then you can build the entire full system, and it all starts with that. If I have the size and the not just the weight, but the size of this will determine the size of the whole system.
That makes sense, yeah. So again, you have to stay true to Searl, and then once you built it like that, then you can come back and experiment with other things.
Correct. But the only, I say the caveat's the right word, the only unknown is, my thing is like, well, nature doesn't know I'm half scaling it. There's no real rule that I'm aware of, except for it says law of squares, but if I just divide everything equally by proportion, why wouldn't it work if I do a half-scale model?
I think it will. Yeah, that would. When you described that to me, that was my first thought. Was you can scale it, you just can't change the dimensions relative to each other.
Correct. So I'm just basically taking this, and everything's reduced 50% in size. The weights do change dramatically. When you go down to that size, they don't just divide, like say it's 8 grams, it doesn't divide equally 50% less to 4 grams. It's like much lighter. So the weights will not be in reflection to the law of the squares. The sizes will be. I'm just taking everything's size here and reduce it 50%.
Okay, I see what you mean. So it may not be the perfect device in terms of, again, the Searl law of the squares requirements.
Correct.
But you may still see some anomalous things. It's a heck of a lot easier to work with. It's a scale model. It's portable. You can take it to different conferences and things like that.
Exactly. And from what I'm looking at now, I will be once I get a 3-ring system, I will be the only one in all of history ever to create a 3-ring system that anyone's ever seen. There's a couple guys on YouTube that have done some 2 rings, and they're sloppy at best. But keeping up the quality standards like in this, doing a 2nd and 3rd ring system with 66 rollers, which has been talked about forever, but there are 0 photographs of any system like that. It's going to be fun to actually like, wow, it's actually 3 rings and it's real. It's not just a bunch of talk. Like, it'll be fun to build that, knowing like, finally somebody's doing it.
Yeah, no, I think that's amazing. I think that is the realization of Searl's dream. You've already started on that path, right?
Yeah.
And so that just takes it that much further, you know?
Right.
And I mean, going back to that Fernando Morris video in 2007, when I saw that, I was really excited, and I'd heard later that he kind of quit working on things, and that was really disappointing. You know?
He almost died a few years ago on a freak domestic violence accident. It had nothing to do with him. But yeah, he almost died, but he recovered, fortunately.
Yeah. And so, you know, to see it come full circle, I guess, to see that video and that kind of sad conclusion to his work, to see that almost reach out and inspire you, I think that should be an inspiration for everybody.
Yeah, I agree.